hello, 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 hello. So, hello guys. I haven't seen you in a while. It's been 4 days. I don't really have the motivation to study because it the semester in my school is about to end, and I just want to rest, man. I just want to rest. I've been grinding this since the start of the year. Like I've already finished K and King's modern approach to programming in C. Now I'm doing this. So maybe like a couple more, like five, seven, maybe 7 or 8 more to the end of 7 or 8 more streams till the end of the sem, and probably I'll tone down the frequency of my streams during the summer. Maybe 3 4 times a week, because I'm going to be um going back home to the province and playing a lot of table tennis, because that's something that I love to do. Or maybe, let's see, I kind of want to do projects instead of just reading from a book. I want to do projects in C because maybe that's where I'll find my motivation, and maybe that's more fun because reading is so boring, honestly. I haven't I don't know why. I used to enjoy reading. Maybe because I'm forcing myself. Maybe. S- the Yeah. So today we're probably just going to read until the till here, and yeah, till here, and I don't think I'm going to be answering this. Not right now. Maybe next stream. Yeah. Okay. So, heap sort, an elegant and efficient sorting method, can be defined from the basic observations of heaps outlined above. This method, called heap sort, uses no extra memory and is guaranteed. Wait. Before we start, I'm going to preface this stream. I'm going to preface that it will be maybe this stream will last 30 minutes. Just a short stream, short reading stream. Not really implementing anything. Yeah. Okay. Let's continue. There's no extra memory and is guaranteed to sort n elements in about n log n steps, no matter what the input. Fortunately, its inner loop is quite a bit longer than the inner loop of quicksort, and it is about twice as slow as quicksort on the average. Mm. The idea is simply to build a heap containing the elements to be sorted, okay, and then to remove them all in order. One way to sort is insert the elements one by one into an initially empty heap. Mm, as in the first two lines of the following code. which actually just implement construct, then do and remove operation. Putting the element removed into the place just vacated by the shrinking heap. Okay. Okay, I don't understand anything. This for next semester. ComSci 1 to 3. I'm not even there yet. And I doubt it will go this in depth, but sure, if I want to be cracked, this is the way of being cracked. Small steps. The priority queue procedures are used only for descriptive purposes. In an actual implementation of the sort, you might simply use the code from the procedures to avoid unnecessary procedure calls. More importantly, by allowing heap sort direct as array, which loop the priority queue resides in. Okay. This computation is arranged so that the sort can be accomplished in place. In the heat of the summer, so different from the rest. Figure 11.6 shows the heaps construction as the keys sorting example are inserted in that order into an initially empty heap. Figure 11.7 shows how those keys are sorted by removing the X and removing the T. Where the freak is the X? Is this a misprint? Okay, A B C D F G H I J K L M N O P Q R S. Okay, S T here, then A B C D F G H I J K L M N O P Q R S. Can S be at the right side? I mean, I think it's just convention that it's put to the left. Maybe because when reading in order, pre-order, post-order, we just yeah, we start from the left. That's why they put it on the left, maybe. If not, then I don't know. Oh wait, what? A B C D F G H I J K L M N O P Q R S T. Oh, T is put. Oh, but S is not put to the right. A B C D F G H I J K L M N O. Okay. It's actually a little better to build a heap by going backwards through it, making little heaps from the bottom up as shown in figure 11.8. This method views every position in the array as the root of a small heap. Takes advantage of the fact that down heap will work as well for such small heaps. As for the big heap, I do not. I have zero clue what that means.
I'm Jewish and I support the state of Israel. I voted for
Working backwards to the heap. Ever notice the root of a heap? Okay, which is heap ordered. What? Is a possible for the root. Down heap finishes the job. Okay, what the fuck? I don't know. I have zero clue. We've already noted that remove can be implemented by exchanging the first and last elements. Decrementing n and calling down heap 1. This leads to the following implementation heap sort. I don't. Oh my god. Okay. Here we again abandon any notion of hiding the representation. The heap. Assume that down heap has been modified to take the array and heap size as the first argument. The first for loop implements construct, then the while loop exchanges the largest element with the last element and repairs the heap as before. What am I doing? It's interesting to note that though the loops in this program seem to do very different things, they can be built around the same fundamental procedure. Bro, what? Figure 11.9 illustrates data movement in heap sort by showing the contents of each heap operated on by down heap. For a sorting example, just after down heap has made the heap condition hold everywhere. The reason for this property is that most of the heaps processed are small. For example, to build a heap of 1 to 7 elements, the method calls down heap on 32 heaps of size 3. This is just math, man. I mean, math is fun, but I don't want to do math right now, bro. This property is not of particular importance for heap sort, since time is still dominated by the analog end time for sorting. Oh, okay. Oh, okay. Wow. Uses fewer than slightly higher bound, say 3n. More careful count based. Mm. Figures 11.10 and 11.11 show heap sort in operation on a larger randomly ordered file. Figure 11.10 process seems to be anything. Mm, 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 Many applications of priority queues, we don't want the records. Mm, That's the Q entry for uh jump ratio. The information that we have done. Although we don't have space. It's easy to translate the algorithms. In fact, so. Okay, guys, so that's it. Sorry for a this interesting stream, cause I don't understand anything. Like I'm just reading. Maybe it'll pay off. Who knows? Maybe we'll get married one day.